Hello students, welcome to Narayana Live Classes. Let us see today's assignment based on the structure of atom. The first question, in Rutherford's experiment, fast moving dash particles were made to fall on a thin gold foil. So what are the fast moving particles here? Alpha particles. So alpha particles, the fast moving alpha particles were made to fall on a gold thin foil. Okay, the next question. So alpha particles are, so what is alpha particles here? Alpha particles are doubly charged helium ions. Doubly charged helium ions, He2+. So how to represent He2+. And the next question, alpha particle scattering experiment was made by, see here, alpha particle scattering experiment was made by Ernest Rutherford. So he is a British New Zealand physicist, Ernest Rutherford, right? So let us see our answer. So what is our answer? Alpha particle scattering experiment was made by Ernest Rutherford. And the next question, Ernest Rutherford selected a gold foil for his experiment. This gold foil was about a dash atoms thick. So how many atoms thick a gold thin foil? 1000 atoms. See why we are considering the gold thin foil. See here, gold is having high malleable character. Due to the malleability nature here, we are taking gold thin foil. So now what is our answer? It is 1000 atoms thick. Next question, alpha particles have a mass. So how we are representing alpha particle? He2+, right? So what is the mass of helium? Is 4. Right? So 4U. The next question, in Rutherford's experiment, most of the fast moving alpha particles passed dash through the gold foil. Most of the fast moving alpha particles. See here, when we observe the Rutherford nuclear model, right? When we pass alpha particles pass through the gold thin foil, we can observe most of the alpha particle going in a straight line direction. So because of what nature? Most of the atom is empty space. Most of the atom is empty space. So we can observe this right line direction. Right. So let us see our answer. So in Rutherford's experiment, most of the fast moving alpha particles passed straight through the gold foil. Right? And the next question, in Rutherford's experiment, how many alpha particles out of every 12,000 particles appear to rebound? So, how many particles are out of, for suppose if you consider when we are passing these fast moving alpha particles through the gold thin foil, if you consider out of one alpha particle, out of 12,000, one alpha particle is going to rebound it. See, observe here. So you can observe in this picture. See here, which is in 180-degree direction. So right. So what is our answer here? One alpha particle out of 12,000, one alpha particle is going to be a rebound. Right. And the next question. Rutherford concluded from the alpha particles scattering experiment that most of the space inside the atom is. So most of the space inside the atom is empty. So due to that reason, see here, if you observe the fast moving alpha particles when we pass through the gold thin foil, they are going into a straight line direction. Right? So most of the atom is empty. So what we can say, most of the space inside the atom is empty. So let us see the next question. Rutherford concluded from the alpha particle scattering experiment that the dash charge of the atom occupies very little space. So here we can observe a very little space. What is the charge of the atom which is placed in the, right? Particularly in, if you observe that, the positively charged body which is present in the inside the atom, and that we can say the positively charged body. What is the positively charged body which is present in the inside the atom? Is nucleus. Right. So our answer, what is our answer? positive. What is the charge of the body? Occupies a very little space. Positive charge of the body. Right? The next question. Rutherford also calculated that the radius of the nucleus is about dash times less than the radius of the atom. Right? How many times the radius of the nucleus is less than the radius of the atom? 10 to the power 5. Right. So next one, Rutherford model of atom is also known as, the Rutherford model of an atom is also known as nuclear model of an atom. Nuclear model of an atom. I hope you all understood today's assignment, children. We will meet in the next assignment. Thank you everyone.